Hey there, everybody. We are going to talk about dividing radicals in this video. And we have some different scenarios that we'll talk about a little bit more as we go through. In general, if we're dividing radicals, right, a radical in the numerator and denominator of a fraction, we're going to start by dividing the coefficients, and then we're going to use the quotient rule, very similar to the product rule, just deals with division. If we have two radicals of the same index, okay, we can turn that into really just the nth root of whatever a divided by b is. Okay, and then we're going to have a single radical, and we can simplify from there. So let's look at one. Okay, radical on the top, radical on the bottom. Remember, we're going to start by dividing the coefficients. 28 divided by 4 just gives us 7. And then since we have two cube roots dividing, we can turn that into a single cube root, and then the radicand will be whatever we get when we do negative 16m to the 6th divided by 2m. So when we do that division, we get negative 8m to the 5th. And now we just got to break that cube root down. So let's see. To deal with a negative 8, we can actually take the cube root of that. So that'll go over here. And then for m to the 5th, we're going to break it into m cubed and m squared. So this really is 7 times negative 2m times the cube root of m squared. So we're going to get negative 14m cube root m squared. So not too bad. Okay, divide the coefficients, divide the radicals, break it down from there. Okay, but sometimes we can't divide and we can't reduce. So what do? Well, this is what we call rationalizing a denominator. We don't like to have the square roots of things in the bottoms of fractions. Okay, we don't want it to be in the denominator, just like we don't want imaginary numbers to be in the denominator. We don't want negative exponents anywhere. We want to keep radicals out of denominators. The reason for that is it makes that radical expression easier to combine with other radical expressions. It's easier to manipulate if they are not in the denominator. So we have two cases. Okay, if we have a monomial in the denominator, to cancel out the radical, we're just going to multiply by itself, essentially. If we have a binomial, we're going to have to multiply by something called the conjugate, which should sound familiar because we did it with complex numbers to get I out of the denominator. So very similar. So let's see what I mean here. I have a square root divided by a square root. I can't divide the 28 by the 3 or reduce it. I can divide the a's, though, so I'm going to do that. So I get 28 a to the 4th over the square root of 3. So what I'm saying is, to get rid of that square root of 3 in the denominator, I need to multiply the denominator by the square root of 3. I'm also going to multiply the numerator by the square root of 3, because if I multiply by the square root of 3 over the square root of 3, this is essentially just equal to 1. If I multiply something by 1, it doesn't change the value. We've seen this strategy quite a few times this year. So when I multiply my numerator by the square root of 3, I end up with 100. Nope, just kidding. When I multiply by the square root of 3 here, I get 84. Okay, and we have 84a to the 4th here. When I multiplied my denominator by the square root of 3, okay, the square root of 3 times the square root of 3 is the square root of 9, and we're in luck because that's really just 3. So we get 84a to the 4th over 3, and now we can just focus on breaking the square root in the numerator down. Okay, I can break that down into 4 times, what would that be, 21. And then a to the 4th, I can already take the square root of that. So we end up with 2a squared times the square root of 21 all over 3. So notice we have a radical in the numerator only Nothing in the denominator, no radicals down there. Okay, just a nice number. So let's look at another one like that. Okay, again, I have something that I can't actually divide, right? I could reduce a little bit if I wanted to. It's not going to be super helpful though. The best way to get rid of this square root of 12 is just to rationalize, okay, which is what we call multiplying by that square root on the top and bottom of our fraction. So when I multiply my numerator by the square root of 12, we get 3 times the square root of 24. When I multiply the square root of 6 times the square root of 12, I get the square root of 72. And then when I multiply my square root of 12s together, I get the square root of 144. Okay, well, we've got quite a bit of cleaning up to do here. Okay, let's start in our numerator. Let's break down those square roots. So the 24 is going to break down into the square root of 4 times the square root of 6. That square root of 72 will break down into the square root of 36 times the square root of 2. And then, of course, we know the denominator is going to become just 12 now. So again, let's clean it up a bit. Okay, 3 times the square root of 4, so 3 times 2 is 6. So we get 6 square root of 6 plus, and then we've got 36 under our square root there, which turns into a 6. We've got the square root of 2 all over 12. And now we can actually do a little bit of reducing here. Okay, I can't reduce with the radicals, but the coefficients of 6 can reduce with that 12 to become 1/2 and 1/2. Right, 6 over 12 is 1/2. This 6 over 12 is another 1/2. So we really have 1 square root of 6 plus 1 square root of 2 all over 2. Okay, but keep in mind, I cannot combine those radicals in the numerator together because they are not common radicals. They have the same index, but they do not have the same radicand. We cannot combine them. So let's look at what we do when we have a binomial in our denominator. Okay, we can't just multiply by the square root of 6 anymore. It's not going to get rid of the square root. In this case, we have to multiply by the conjugate of the denominator. The conjugate of 3 minus 4 times the square root of 6 is going to look identical, except we're going to change that middle sign to plus. Okay, and once again, we have to multiply the numerator by the same thing, so that the thing we're multiplying by here is all really just equal to 1. So this is going to be kind of a mess, right? There's a lot more that goes on here. There's a lot more involved. So we need to FOIL in the numerator and the denominator. My numerator is going to become 24 plus 32 square root of 6 minus 3 square root 6 minus 4 times the square root of 36. Okay, and yeah, there's some stuff we can break down. There's some things we'll combine. We'll come back to that. Okay, let's multiply the denominator here as well. So again, I'm going to FOIL. 3 times 3 is 9. 3 times 4 square root 6 is 12 square root 6. Negative 4 square root 6 times 3 is negative 12 square root 6. And when I multiply negative 4 square root 6 times positive 4 square root 6, we get negative 16 square root 36. So let's go through, combine, break some things down, and clean it up. So in the numerator, these both have square root of 6s, so they're going to combine. So we've got 24 plus 29 square root of 6, and then this square root of 36 is really just 6. Negative 4 times 6 is a minus 24. Okay, so there's our numerator. We can come back and clean that up a little bit more in our next step. In the denominator, hopefully you notice that these middle terms are going to cancel out. This square root of 36 becomes a 6, so we're not going to have any square roots in the denominator, which is our really entire goal of this. Okay, so we really have 9 minus 96. So let's go back through. Our 24s in the numerator cancel, leaving us with only 29 square root of 6. 9 minus 96 is negative 87. So let's check and see, can we reduce? Okay, 29 over negative 87 is just negative 1/3. So this turns into negative square root 6 all over 3. Now I know this is a little tricky. There's a couple different things that we can do with division. If you can divide, you should always divide first. If you can't divide, that's when you need to consider rationalizing. Okay, so that is it for this video. Sorry it's a bit long. Have a great rest of your day.